So, all right. So we'll give people 1 or 2 minutes to join us, and then we'll introduce our speaker today. All right. So I would like to welcome you to the second talk, the second lecture in the annual lecture series at the Center for Philosophy of Science. Before introducing our speaker today, I would like to remind you of the coming events at the center. Next week, we will have 2 lunchtime talks at noon Eastern Time. On Tuesday, a talk by Daniel Wenner from Carnegie Mellon University on clinical research as basic structure and the ethics of health research priority setting. And on Friday next week, Center Fellow Chris Weaver, who we've been hosting this semester at the center with great pleasure, we'll be talking about Hamiltonian mechanics and causation. Both talks are at noon on Tuesday and Friday. If you're interested in any of these talks, hopefully in both, please go to the center's website, look for the calendar, and you'll find a link to register and you'll receive a Zoom invitation. And we hope to see many of you for this lecture. All right, today it's my great pleasure to introduce our speaker, Elaine Landry, who he is a professor of philosophy at University of California, Davis. She's a philosopher, one of the leading philosophers of mathematics, but also has broader interest in history and philosophy of science, as well as ancient philosophy. She's published widely in the philosophy of mathematics, including she has edited a book on categories for the working philosopher with Oxford University Press, and she's published really widely on a range of topics in the philosophy of mathematics, on category theory, mathematical Platonism, mathematical structuralism, and so on and so forth, as one say, in the best journals in the field. So we are delighted to have her today, and the screen is yours.
Thank you very much. So first of all, thank you to the organizers for being so helpful, for the invitation, and for making this process a very easy process. Hopefully we won't have Zoom problems. So I'm just going to attempt to share my screen right now.
Wonderful, seems to be working.
That's always a good thing. Okay, can everybody, well, I'm hoping you can all see the screen, and if you can't, you can let me know. As was mentioned, my field of interest is philosophy of mathematics, and that ranges from category theory to Plato. And today I'm going to hopefully make a connection between those interests. So I'm going to start with a bit of a story. Hopefully it's going to be a funny story. So when I was finishing up my master's, which was in mathematics education, I couldn't decide, do I go on in philosophy or do I go on in mathematics? And I spoke to my advisor in mathematics, and his response to the thought that I would go on in philosophy was, why would I want to sully my mind with such nonsense? Which was better than the advice I got from my philosophy mentor, which was, if I went on in mathematics, I would never find a husband because no one wants to marry a woman who's smarter. So I chose philosophy, risking it all. One of the things that I think struck me the most as I entered in philosophy of mathematics was there wasn't a lot of care given to what mathematicians actually do, and that philosophy of mathematics had really become an activity of philosophers, which was great, but it wasn't grounded in the practice of mathematics to the extent that I wanted it to be. And I understood the concern about sullying my mind with nonsense. So today, hopefully, I won't sully your mind, and perhaps I'll convince you that there is concern about the role that metaphysical inquiries play in philosophy of mathematics. And there is a way in which we can sidestep some of those. So hopefully I will convince you of that. So here are my aims. There is a handout. I think someone was going to post that in the chat function, but it's not necessary. So I'm going to carve out what I call an as-if interpretation of mathematical structuralism by attempting to disentangle what I call methodological considerations from metaphysical ones. So I'm going to begin first with Plato, and I'm going to show that much philosophical milk has been spilled by conflating the method of mathematics with the method of philosophy. And in fact, I'm going to argue that that conflation continues. I'll use my reading of Plato as well to pull out what I call this as-if interpretation. The idea here being that we treat our mathematical hypothesis as if they were first principles, all the while realizing they are not first principles. And the reason we do treat them as first principles is to solve mathematical problems. I will extend the as-if-ism to modern mathematics, where the method of mathematics becomes the axiomatic methods, so that instead of talking about as-if hypothesis, we talk about as-if axioms, and we take those axioms to implicitly define our objects. I then pause to note the conflation of mathematics with the method of philosophy, and I give an instance of that with the Frege-Hilbert debate. I then use that debate to pull out the distinction between if-thenist, which is a common philosophy of mathematics or account of mathematics, from as-if-ism. And then finally, I'm going to use the interpretation I offer to break Benassarath's dilemma by showing that there are two types of existence at play. So my overall lesson will be, if we shift our focus from solving philosophical problems to solving mathematical ones, and in so doing, avoid conflating the method of mathematics with metaphysical considerations, we'll see that we can, methodologically interpret what I call as-if structuralism, right? And we can use that to provide an account of both the practice and the applicability of mathematics. I have two screens going, and I'm not sure which one I should be looking at. So I'm going to begin with Plato. Here's my account of Plato's divided line. The reason why I have two screens going is I'm running my iPad. So for the focus of this talk, we're not going to be talking about that side of the divided line. We're only going to be talking about this side here. And what I want to argue is Plato himself is not a mathematical Platonist. So that if we look at what Plato says in the divided line and in book 7, what he says very clearly is the methods of mathematics and the methods of philosophy are distinct. The mathematician uses the hypothetical method. The philosopher uses the dialectical method. And as a result of their differences in method, there's a difference in both their epistemology and their ontology. So if we look down to epistemology, right, in some sense, we have knowledge, both philosophical knowledge and mathematical knowledge. But mathematical knowledge for Plato is less clear than philosophical knowledge. And it's less clear because the method is different. And because the method is different, the objects are different. So the objects in mathematics, he calls objects of thought. The objects of philosophy are objects of understanding. As a result of that, here we need forms themselves. Notice over here, nothing. We don't need forms in mathematics. We need, however, to be able to talk about the square itself, the triangle itself, the odd, the even, right? These are our objects right here. But those, again, are objects of thought. So I'm going to use this account of Plato's philosophy of mathematics to carve out, again, what I've called as-if-ism. So Plato kept a clear distinction between mathematics and metaphysics, and the knife he used to carve out that distinction is method. So the mathematical method reads down from a hypothesis towards a conclusion with the purpose of solving a problem, a mathematical problem. Here's what Plato says. The soul is forced to use hypotheses in the investigation of it, not traveling up towards a first principle, since it cannot escape or get above its hypothesis. And second, by using images, diagrams he has in mind here, of those very things of which images were made by the things below them, so forth and so on. The philosophical method, in contrast, reasons up from a hypothesis towards a first principle. And what that's supposed to do is to tether the hypothesis. Only then can he reason down towards the conclusion. And the aim here is to solve a philosophical problem. And here's what Plato says. Also understand that by the other subsection of the intelligible, I mean what reason itself grasps by the power of dialectical discussion, treating its hypotheses not as first principles, but as genuine hypotheses. That is, as stepping stones in the link of a chain in order to arrive at what is unhypothetical and the first principle of everything. Having grasped this principle, it reverses itself, keeping hold of what follows from it, comes down towards a conclusion, making no use of anything visible at all, but only of forms themselves, moving on through forms to forms and ending in forms. Clearly, then, forms are needed for the dialectical method. So I'm not taking truck with the idea that Plato was a Platonist. Clearly, Plato, Platonist. What I am objecting to is the characterization of Plato as a mathematical Platonist. So again, these differences in method demand both differences in epistemology and ontology. So mathematical method requires objects of thought and yields what Plato says is a kind of knowledge or true opinion. Philosophical method requires objects of understanding. These are the forms, and yields knowledge itself, or what he calls understanding. So even Glaucon is shocked to hear that philosophy as a science is now held to be clearer than mathematics. Here's what Glaucon has to say. I understand, though not adequately. You see, in my opinion, you are speaking of an enormous task. You want to distinguish the part of what is, or that aspect of reality, and what is intelligible, the part looked at by science of the dialectical discussion, as clearer than the part that is as something truer and more exact, looked at by the so-called sciences. Those for which hypotheses are taken as first principles. And although those who look at the latter part are forced to do so by means of thought, rather than sense perception, still, because they do not go back to genuine first principle, but proceed by hypothesis, you do not think they have true understanding of them, even though they are intelligible. And you seem to me to call the state of mind of geometers and others of that sort thought, but not understanding. Thought being intermediate between belief and understanding. So sometimes Plato refers to the epistemic kind of state of the mathematician as having true opinion, sometimes as a kind of knowledge. So the mathematician's hypotheses here are taken as if they were first principles, but they are not. And therein lies the confusion, right? The confusion is either he takes them as first principles, or he takes them as hypotheses, but like the philosopher, has to give a first principled account of them. So what we're told is students of geometry, calculation, and the like hypothesize the odd and the even, the various figures, the three kinds of angles, and other things akin to these in their investigation, regarding them as known. These they treat as first principles, and do not think it necessary to give an argument or account of them, either to themselves or to others, as if they were evident to everyone. And going from these first principles through the remaining steps, they take their start from these, and pursuing the inquiry from this point on consistently, they arrive or they conclude in full agreement at the point they set out to reach in their investigation. So again, what the mathematician does is they set up their hypothesis with the aim of solving a problem. So the purpose of the mathematician's method, which begins with hypotheses as if they were first principles, is to solve a mathematical problem. It is not to solve a philosophical problem. It's not to give a philosophical account of what those hypotheses are. So the method of mathematics begins with hypotheses and treats them as if they were first principles. Mathematics then does not need a metaphysics of forms that accounts for or tethers its hypothesis. The method of mathematics is distinct from that of philosophy, and so are its objects, and so is its epistemology. Here's what Plato has to say, that mathematical objects are not as clear or as real as philosophical objects. That is, they're not objects of understanding, but as objects of thought, they are still, quote, concerned with being. That's why he puts them on that side of the divided line. The mathematical method yields true beliefs, that is, beliefs that are reliable guides to solving problems, because they are born out of stable definitions and a stable method. I'm not going to talk today about the role that stable definitions play in Plato, though it is a large role. So only the philosophical method yields, properly speaking, knowledge. That is, it yields true beliefs that are fixed to or tethered by a stable domain of objects, right? They're fixed or tethered by these metaphysical objects called forms. And what that leads us to conclude is that philosophy as a science is founded on the dialectical method and on the stability of its metaphysical objects, that is, forms. Mathematics, in contrast, is a science that is founded on the stability of the hypothetical method and the stability of its definitions. So the confusion that I want to attempt to clear up today is that as philosophers, we've continued to conflate the method of mathematics with the method of philosophy. And the correction I want to make is when I say that a mathematical object exists, what I mean is that I treat my hypothesis as if it were a first principle. And in so doing, I act as if my hypothesis were tethered to an object. So I recognize that my hypothesis is not a first principle. And so my object is an object of thought. It is not an object of knowledge. Now, interestingly, the notion of thought in ancient Greek is also connected to this notion of conjecture. So there is a reason why Plato is using the word thought there. So to give an example of what I mean, I go back to the Meno problem that you might be familiar with or not. We can go over that in the question period. So I treat my object as if it exists, and I do so in virtue of my aim of solving a mathematical problem. So for example, in the Meno problem, I'm asked, what is the length of the side that will double the area of a 2-unit square? Right? That's the question I'm asked. So that's the problem I've set out for myself. So I treat the length of the side that doubles the area of a 2-unit square as if it were an object, but it is not. So it is only because of the stability of the definition of a diagonal, right? So I bring in a definition to help me that I can reason down to the conclusion that the length will be the diagonal of the square. So I use the notion of a diagonal, right? And then I pull in the Pythagorean theorem, right? And then I can construct a square that will double the area by saying, let the length be that diagonal. Now, interestingly, Plato here chooses an example, right, where I can take the length of that. I can show that it's going to double the area of my 2-unit square, but I can't know what that object is, because the length, the actual length of that diagonal is 2 root 2. So what I take Plato as saying here is, look, we don't need that direct access to objects. All we need are stable definitions and a hypothesis. And with those two things, we can solve mathematical problems. Okay. So here's my as-if-ist account that I'm going to pull out of Plato. In mathematics, we treat our hypotheses as if they were first principles, and consequently, we treat our objects as if they existed. And we do this with the purpose of solving problems. So that mathematics as a science is founded on the stability of the hypothetical method and the stability of its definitions. It is not founded on the stability of its metaphysical objects. And now I want to extend this into a modern account. So I extend this methodological as-if-ism to modern mathematics, where now we shift from, Plato's account of the method, reasoning from hypothesis, to the axiomatic method itself. So this engenders a shift from starting with as-if hypothesis to starting with as-if axioms. So I treat my axioms as if they were, and we'll see what we want to take our axioms as. So then mathematics as a science is founded on the stability of the axiomatic method and the stability of its definitions. But now, right, we take our axioms as implicitly defining our objects. So I'm giving my hand away that I'm taking a Hilbertian account of what an axiom system is. Regardless, the stability of mathematics is not founded on the stability of any metaphysical objects. So now we'll look at the Frege-Hilbert debate and see how that plays out in favor of my as-ifist account. So Frege confuses the method of mathematics with the method of philosophy, right? The method that he sees them both having is this method of concept construction. So he takes axioms as first principles and so presumes that we need a stable domain of objects to tether or fix the truth of our axioms. So for the Fregean, axioms as first principles, the primitive terms employed by our axiom must be defined over a fixed domain before the statement of those axioms. That is, they must be logically constructed in the case of arithmetic and Kantian constructed in the case of geometry. Hilbert, on the other hand, takes axioms as if they were first principles that themselves implicitly define objects, so that whatever satisfies our axioms is taken as an object that fixes the truth of our axioms. So again, we have bringing together this notion of stability of method and stability of definitions. So Hilbert takes axioms as implicit definitions over a variable domain, not over a fixed domain, so that the primitive terms are to be defined by the axioms, and the axiom systems themselves are taken as but schema for defining those concepts. I'm sure most of you are familiar with this debate. So now we want to talk about, that's the sense in which they're different. And now we want to talk about what's the sense in which they allowed for an if-thenist reading. So for Frege, the stability of mathematical definitions was justified by assuming the truth of the axioms, right? That's the sense in which he's taking axioms as if they were, axioms as first principles. So truth for Frege is fixed logically in the case of arithmetic, or it's fixed philosophically by Kantian intuition in the case of geometry. So Frege's meta-mathematical account of the method of mathematics is, if the axioms are true, then this theorem can be justified. So we have a schema, an if-thenist schema for how mathematics might work. For Hilbert, however, the stability of definitions is justified by assuming the consistency of the axioms, not the truth. So we have Hilbert's famous quote, if the arbitrary postulated axioms do not contradict each other with their collective consequences, then they are true, and the things defined by means of the axioms exist. That, for me, is the criteria of truth and existence. So Hilbert's meta-mathematical account of the method of mathematics is, if the axioms are consistent, then the theorem can be justified. So we have this if-thenist meta-mathematical account of how we reason in mathematics. So while Resnick rightly points out, both Frege and Hilbert came to reject if-thenism as a meta-mathematical account of the method of mathematics. And I'm not going to go into the story of why they did that, but it will be helpful to see if we shift from an if-thenist account to an as-if account, whether we can have an account that's more in line with Hilbert. So what I will now consider is whether the standard logical if-thenist views can be weakened to methodological as-if views that Plato seems to be offering up. So if you look at if-thenism in philosophy of mathematics, typically they're all taken as logical kind of statements. And what I want to say is, let's, instead of taking them as logical, take them as methodological. I'll explain what that means as we go on. So I'm relying heavily on Resnick's account here. So as detailed by Resnick, Frege himself developed these two forms of if-thenism. So when Frege was critical of Hilbert, he was well aware that there were differing accounts, differing if-thenist accounts that one could offer up. So according to the first account, and I'm going to call this the deductive if-thenist, right? This is the standard one that we see in if-thenist accounts in philosophy of mathematics. So this is sometimes called deductivism. So in a deductivist option, mathematics is in the business of establishing results in pure logic. So for example, we presume that A stands for a quantificational scheme diagramming the supposed axioms, and T stands for a quantificational scheme diagramming the supposed theorem, right? And then we can schematize this or meta-mathematically express this as, right, here are my axioms, and then we can either give an account of this in terms of logical provability or derivability. So this is the standard view that usually gets presented when you read introductory books or even, SEP entries on deductivism. On the second view, what I will call a structuralist if-then view, Frege views a mathematical theory as studying the properties of all structures satisfying certain defining conditions, but he never makes use of the assumption that such structures exist. So again, right, we find this view in Putnam, right, Shapiro, Hellman to some extent. And that's the view that I'm going to be looking at. This is the view that's most in line, right, with structuralism. Now, Putnam takes him in a different route. He gives a model theoretic reading of this. So what I want to point out is that Resnick notes that such a view can rid mathematics of ontological presuppositions while retaining its apparent descriptive character. So this is the part that I want to work out. How can we rid mathematics of ontological presuppositions? Then he says, and reduce the epistemology of mathematics to that of logic. Well, I'm going to reject that part. So the as-if picture that I'm presenting here is a structuralist as-if picture, but it is not a logical as-if picture. And hopefully it'll become clearer what I mean by that. So, noting yet another virtue of the structural if-thenist picture, Resnick further claims that this structuralist option offers a straightforward account of applicability. That is, when one finds a physical structure satisfying the axioms of a theory, the application of that theory is immediate. Again, I'm going to accept that account of applicability. Resnick also notes a final virtue, that a structural if-thenist approach is in line with the development of abstract structures like group theory and topology. I'm going to add in there, and category theory, right? So again, I'm in line with Resnick's reading here. Where we're going to part ways is he's presenting this structural option as an if-thenist option, and I want to present it as an as-if option. So structural if-thenism, right, faces basically two problems. The first one is known as the structure problem. Hellman characterizes this as the home address problem. So if the structural if-thenist option requires set theory as a background theory, we're in trouble, right? Because then we seem to be saying, well, we're going to have to take some theory as true, not as if it were true, but as true. And then we're going to be ontologically committed to that theory. So the concept of structure is usually defined in set theoretic terms, according to some people, not us category theory people. But at any rate, the idea is that you're going to require some background theory, and that background theory is going to have to be read ontologically. However, Resnick is quick to remind us that the structural if-thenist taking this approach need not make use of any existence assumptions of set theory. One may remain agnostic with respect to the existence of mathematical structures. The benefits of such a Carnapian approach, this is what I'm characterizing it as a Carnapian approach. Resnick just says, this gives mathematics a linguistic framework which is referential and thus agrees with the prima facie referential character of mathematical language as used by practicing mathematicians. So again, I want to keep these aspects, this Carnapian aspect, right, this agnostic aspect, and avoid this problem here. The next set of problems that the structural if-thenist faces are known as the consistency problems. And in a lot of the literature, these are separated out. I'm just going to throw them all together. So the first is the vacuity problem. The second is the problem that all consistent mathematical theories will define the same structure. The third is to account for the depth and diversity of mathematics, one must assume that the great majority of mathematical theories are consistent. So faced with these problems, Resnick presents us with two alternatives. We can, again, now we've moved to a meta-mathematical level. We can take the Fregean route of basing the assumption of consistency on a belief in a mathematical reality and truth, which will vouchsafe for the consistency of mathematical theories. And of course, this is the route that Resnick takes, and that's why we characterize Resnick as a mathematical realist. The other way, what I've called this Carnapian route, is we offer up a relative consistency proof, and we do this, and Resnick again gives us the recipe for doing this. We argue that since consistency is a mathematical question, it too must be treated deductively. So the assertion that a given axiom system is consistent must be construed as conditional upon a background theory with respect to whose truth the deductivist can remain agnostic. So again, this is the route of someone who's going to run a relative consistency proof. Again, that's the route that I'm going to choose. So in the literature, this is all kind of standard objections against if-thenism. So the next question is, if we shift from if-thenism to as-if-ism, will we still face these problems? Guess what the answer is. So let's now pause to compare structural if-thenism with a methodologically interpreted structural if or as-if-ism. There's a lot of ifs and ands here. And see if we can't forestall these problems. That is the structure problem and the consistency problem. So let's first recall that the basic premise of Plato's methodological as-if-ism is that mathematics is used to solve mathematical and physical problems. I didn't talk about the solving of physical problems, though that is also in the divided line. And that it's in virtue of these uses, of these methodological uses, that we're justified in taking a hypothesis as if it were true. So there's a bootstrapping that goes on in mathematics. We start out with a hypothesis, right? In taking our hypothesis as if it were first principle, we've now got reference. We've got reference to objects, right? We use those objects, right, to attempt to solve a problem. If we can solve that problem, great. We go back and we bootstrap and we say, that was a good hypothesis. If, right, we don't solve our problem, what do? We either go back and we change our hypothesis, or we say, this problem itself is not set out in a clear way. And those are the examples that Plato shows us over and over again. There aren't a lot of mathematical examples. So building off of that, let's presume that the basic premise of methodologically interpreted structural as-if-ism, I know I gotta get a better name of that, is that mathematics is also used to solve mathematical and physical problems, and that it's in virtue of these uses that we are mathematically justified in taking a set of axioms as if they were consistent. And then when we face those structure problems and the consistency problems, and meta-mathematically, we're justified in taking our background theory as if it were true. Notice the as if, right? So at a mathematical level, our justification for using our objects is to say, well, I'm going to assume, right? I'm going to treat my axioms as if they were consistent. That's going to get me reference to objects. And then someone says, well, wait a minute. How do you know it's consistent? Well, I can run a relative consistency proof, right? So I can meta-mathematically justify that claim by saying, well, the background theory that I'm using for my relative consistency proof, I'm going to treat that as if it were true. But notice there's as if in both of these cases. I am not ontologically committed to that background theory, and I am not committed to the claim that there is only one background theory. So taking this methodological as-if-ist Platonic route, by placing our focus on what is needed for the practice and the applicability of mathematics, we are neither committed to the unconditional consistency of our mathematical axioms, nor to the unconditional truth of our background theory. And again, it's these ideas, the idea that we need unconditional consistency claims or unconditional truth claims, it's those ideas that lead us astray. It's those ideas that lead us from mathematics to metaphysics. So in all cases, it is still methodological considerations and not metaphysical ones that condition our as-if-ist assumptions, both the assumption of the consistency of our mathematical axioms and the assumption of the truth of our background theory. So again, you see this over and over again in mathematics, particularly when you look at the structuralism literature. It's like, oh, well, you could be a structuralist at this level, but at a mathematical or a meta-mathematical level, no, you can't, because you have to assume a background theory. Well, I assume that background theory, but I assume it as if it were true. So what we get then is an enhanced version of what I've called structural as-if-ism, which is much like Maddy's recent account of what she's called enhanced if-thenism. So we agree with Maddy that mathematics is a matter of figuring out what follows from what, where the concepts and axioms in the if part are chosen with the eye of facilitating important mathematical goals. But we don't analyze the what follows from what in terms of a deductivist if-then reading. So again, when Maddy goes to analyze what she means by what follows from what, she takes this deductivist if-then reading, this logical interpretation of what follows from what. And what I want to do, instead of analyzing the what follows from what in terms of this deductivist reading, rather to read it or to resolve it in terms of a structuralist reading, right? That we have a system that satisfies our structure. That's all that comes down to. So the methodologically interpreted structuralist as-if position, again, if you people want to give me some suggested names for my position that aren't as long, that would be really helpful. So it's even more enhanced than Maddy's enhanced if-thenist position. So what we say is some of our commitments to mathematical objects will be made in light of mathematical practice with the goal of solving mathematical problems. Some will be made in light of mathematical applicability with this goal of solving physical problems. And some will be made in light of philosophical considerations with the goal of solving metamathematical problems. But notice, right, we've got mathematical practice, mathematical applicability, philosophical considerations, and none of these get solved by appeal to metaphysics. So here's some ways to kind of rule this out. So with respect to these philosophical considerations, does this mean we'll have to call in model theory to solve the problem of what we mean by satisfaction? Because remember that on the structural as-if account, we're talking about systems that satisfy a structure. So we've got to give an account of what we mean by satisfaction. Our best account of what that means is model theory. So yes, we're going to have to call in model theory. Does that mean that we have to take models as possible or actually existing, right? That's what Putnam does when he tries to work out his if-thenist account. And I'm arguing, no, it doesn't. And it doesn't because, again, that gets brought in to solve a metaphysical problem of fixity of reference. Does that mean we have to take structures themselves as actually or possibly existing, as Shapiro and Hellman suggest? Again, no, it doesn't. right? Because remember, what we're doing is we're saying, I'm going to talk about structures, right? But I don't need a background theory of structures. Will we have to call in some meta-linguistic framework to frame what we mean by the concept structure? Yes, we will. Right? We need a background theory that's saying, look, if I'm going to talk about structures as concepts, then I need a background theory that gives me, structures as objects. But does that theory have to be set theory? No, it doesn't. Right? As I've argued numerous times, it can also be category theory. In fact, I've argued that we're better off choosing, if we want to give a more comprehensive linguistic framework for our talk about structure, that we're better off taking that route. Okay, so what I've done so far is I've worked out this as-if-ist account of mathematics. I've shown that that as-if-ist account can be used to dismiss some of these metaphysical problems that really don't have to do with the practice or the applicability of mathematics. And now, because, as philosophers, we become our own worst enemy, I think, okay, now someone's going to say, well, that's just fictionalism, right? You're treating mathematical objects as if they were real. And what I want to say is, it's not fictionalism, it's realism. So what does that mean? So recall Benacerraf's dilemma. Benacerraf's dilemma says either we have a shared referential semantics, that is a referential semantics for mathematics that matches that of, natural language, or you could take it of science, or we have a reasonable epistemology. By reasonable here in this paper, he meant causal, but let's not get into that debate. We'll just stick to reasonable. So as noted by Resnick, right, if we adopt this Carnapian approach, this approach of taking mathematical theories as linguistic frameworks, that gives mathematics a framework that's referential, right? So that what we have is, in virtue of adopting this framework, we have a way of talking about objects. So we have a shared Tarskian semantics. Our mathematical statements are made true by reference to mathematical objects, just like our scientific statements are made true by reference to physical objects. Right? So the notion of reference, the notion of satisfiability, it's the same. What is different is not the notion of reference, it's the notion of existence. So we have a reasonable epistemology in mathematics. We come to know mathematical objects via the axiomatic method as objects of thought. We treat them as if they exist because we can take our axioms as if they were true. So we have this notion of existence as an as-if notion. So the difference is that in mathematics, existence is a consequence of truth. And in science, truth is a consequence of existence. So I'll just pause to let that sink in. Remember Hilbert's quote, right? If your axiom system is consistent, then you're licensed to say that those statements are true, and you're licensed to say that the things they talk about are existing. So in mathematics, there's nothing more to existence than as-if existence. That is existence on the basis of what we say. So we construct a linguistic framework, right? I can say I have these sentences. In virtue of what I can say in that framework, I can say this thing exists. So mathematical realism, or what I call as-if mathematical realism, is not idealism, it's not nominalism, it's not fictionalism, because there's no other sense of existence in mathematics. It's not like we say, okay, they exist, we take them as if they existed, but they don't really. There is no other notion of existence. And that, remember, Plato himself says there is a sense in which they exist. They have a sense of being. In science, however, there is more to existence than as if existence. That is, there's existence on the basis of what we can show. And I was really tentative of bringing in the whole say and show distinction. I really don't mean that in any Wittgensteinian sense, so I hope that no one's going to hold me to that. But I think there is a difference, right? So as if scientific realism is idealism, it is nominalism or fictionalism. Why? Because there is another notion of existence in science, right? So there are limits to this Carnapian approach. I can talk about mathematics as a linguistic framework, and in virtue of what I can say in that framework, I can say this thing exists, or I treat it as if it exists. But when I do that in science, I notice that if I take a scientific theory as a linguistic framework, the world is where things exist in science. So elsewhere, I've made this distinction by saying that mathematics is a language. It's not a science. So again, and these are some confusions that I'm still working on. So in this talk, I've talked about the first one. So by conflating mathematical issues with metaphysical ones, we've made mathematics into a science, and so have proclaimed that mathematics must have a subject matter, right? Whether that subject matter is objects or structures or possible worlds or so forth and so on. And, right, by not considering the fact that we do have two different notions of existence at play, by conflating metaphysical issues with mathematical ones, we, and I really mean structural realists here, have made science into a language and have proclaimed that physics has no subject matter. So again, what I want to point out is that unless we take the time to separate out methodological issues from mathematical ones, from metaphysical ones, all of those get run together, and we end up reading mathematics as a science, and we end up reading physics as a language. And that should be a reductio for something has gone wrong. And what I'm trying to do here is to say, let's pull back and let's look at what's gone right. And that's all I have. I'm going to stop.
All right. Thank you very much for this amazing lecture. Let me remind you how we're going to be proceeding for the Q&A. If you have a question for our speaker today, please go down to the bottom of your screen and click on the Q&A button. Just write your name and I will promote you to the status of panelist, and then you can directly ask your question to Elaine. So it's going to take me 1 or 2 minutes, so please bear with me to do that. All right. Could you exit share screen?
Expert screen share? Yep, absolutely. Okay.
All right. Hey, the floor is yours, or the screen is yours. Please go ahead.
You're talking to me. I'm sort of an interloper here. I'm not part of your department. You want to let somebody from your department go first?
No, please go ahead.
Okay, well, all right. It's okay.
It's the beauty of Zoom.
No, it is. But I just wanted to give you the chance to.
Please go ahead.
Thank you. Well, look, Elaine, that was great. And believe it or not, I think a lot of what you say is right on the mark, but I would express it very differently. But let me see if I can bring the two sides together by suggesting the following. You think that all we have to do is take the axioms as if they were true and you get reference. And that's similar to Carnap, who says you simply have to specify the linguistic framework, and then you've got the internal question, do the objects of that framework exist? just becomes true. You can actually either prove it within some things you have to prove within the system, but other things you just get to assume that they exist. Now, the thing that I'd like you to think about is, doesn't that assume a principle? The following principle, because Carnap was a semanticist. So if the internal every framework gets you to the right objects, there must be some way of specifying this principle, that you specify the framework and then the right objects are there for the terms of the framework to denote them. So in your case, it would be something like this. You take the axioms as if they were true. Well, then you need to have, so let's just take piano number theory. You take the axioms as if they were true, and then you get the right objects because you say, then you get reference. So that means for you, you have to have an as if existing number one, an as if existing number two, an as if existing number three, and so on and so forth. And you need that because you have to be able to account for the semantics or the meanings of how those terms, the numerals 1, 2, and 3, contribute to the meaning of the whole. So don't you require at least a principle that says, if you specify the axioms, let's just focus on the consistent theories now. Once you specify the axioms, then your as-ifism requires the principle that specifying the consistent axioms, then there are, or there is, some as-if objects that make the axioms true. Now you need to then specify what those as-if objects are. That seems to be the way to connect up the kind of thing you're doing, which I think is right, with something similar that I'm doing, but I would express in different terms. But I'd just like to see if you think that that's an accurate characterization of a missing principle that Carnap, that I think is missing from this particular development as it stands.
Okay, so first, and I don't know that it much matters, but so there's two as-if-isms at play. So there's one at a mathematical level that says, if my axioms are consistent, then I get truth, and then in virtue of truth, I'm going to get reference, right? So that's kind of the Hilbert. And then at a meta-mathematical level, right, you then say, okay, well, hold on, I'm going to need some assurance that those are consistent. So you run a relative consistency theory, you take some background theory as true, and you say, well, relative to this. So I just wanted to say that because you had said, you know, your schema runs something as axioms as if they were true, then reference. But for me, it's axioms as if they were consistent, then reference. But I think your point still stands. So let's take the piano axioms, for example, right? So take the piano axioms. We say, I'm going to act as if those axioms are consistent. And it seems like what you're saying is, out of that, I then generate the object one, then the object two, then the object three, so that I need some schema that's telling me how I'm getting those objects individually. And I guess the way I'm thinking about it is, I get the objects themselves as totality. So what I do is I say, oh, well, here's a system, you know, take some set theoretic system, or take strokes in as Hilbert would suggested. And I say, well, this system satisfies that. So now I'm going to be committed to the objects in that system. So I don't know if, so on my kind of take, I'm committed to all of the objects in the system. And it seems what you are asking is you want those objects individually. So is that the right reading of what's going on?
I think if you have a feel for the semantics and the meanings of the mathematical terms in the language, then the the numeral 1 is going to have to signify something different from the numeral 2. Otherwise, we wouldn't be able to distinguish claims in which the numeral 1 occurs from the claims in which the numeral 2 occurs. So I'm suggesting that you're going to need something like an as-if 1 and an as-if 2. And for every well-defined term of the consistent mathematical theory, you're going to need an as-if object in order for that to play a role in the semantics and the meaning of that particular mathematical claim.
Now I'm worried. So here's my worry. My worry is, are these as-if ones and as-if twos, are these not just the metaphysical objects I was trying to avoid?
Well, that is a question, but there's a way to address that.
Okay.
And of course, but I won't get into my own work on this, but I would say that these are objects that encode the mathematical properties. They don't exemplify them. And as such, they're very thin kinds of objects. All you have to do because all you have to do is to describe what properties an object has, and you get an object that encodes them. That's a pretty weak, metaphysically thin kind of existence. But it then gives me, for each of those mathematical theories that are consistent and that have these distinct terms, it gives me a distinct abstract object that encodes just the properties attributed to that object in the theory. So I would say, yes, you do get some objects, but they're not the full-blooded kind of objects you get in physics. So that's why I was thinking that we have very similar kind of views, but I would express it a little differently, because I think you do need to take the semantics, the significance of the different number theoretic or mathematical theoretic terms, the distinct, well-defined terms of the mathematical theory seriously. What do those terms signify once you agree that the axioms are consistent and they're as if true? Because then that's key to giving an analysis of what the meaning is of the different mathematical claims. It has to be built up from the meanings of the parts. And you're going to need as if ones, as if two, and so on in order to make that semantics work. Just as Carnap needed objects, he needed a principle that got him from you specify the framework. The right objects are there for the semantics to make that framework hold and the internal question to be answered yes. Of course, those objects exist. Anyway, just a thought. That's something for you to think about. As I say, I mean, in many ways, it's a kind of pluralist view, and that's a good thing. And I think it's preserves the insight behind if-thenism in a proper form. And I think all that's very good. I just think that there's just one little extra step that you need to take. It will seem like it's going back on what you said before, but there are theories out there in which that step does preserve your intuition.
Okay.
Anyway, I'll let somebody else go.
Yeah, I guess the only my metaphysical spidey senses in the back going,
I know.
Look,
oh,
I've just got platonic objects.
Metaphysics has a bad name ever since Carnap.
Platonic objects.
Yeah, that's right. I understand. I understand where you're coming from. Very good. It is a good talk. Thank you.
Thank you very much for joining us. Chris, the floor is yours.
I think you're muted.
There we are. Can you hear me? Anyway, sorry about that. I was just saying thank you so much, Professor Landry, for such a clear talk. I really enjoyed it. I learned a lot. It was very, very clear. Good to follow. Anyway, so I have two questions. I'll just limit myself to one and then get back in the queue. So my first question is about the historical part of the project, where you were discussing Plato and whether Plato was a Platonist with regard to mathematical objects, not necessarily, perhaps other abstract forms and the like. So I thought that, and I'm leaning on Bernstein and others, I thought that in Plato's corpus, in some places in the Phaedo and other places, there's a faculty, a special kind of faculty that we use when we do the science, when we engage in the sciences, when we engage in mathematics, dianoia or something like this, and that there was a debate in Plato's scholarship about precisely what the objects of that faculty are when we engage in science and mathematics. So some people maintain that they're the object of this particular faculty are like abstract images of some sort, or they're forms. But it seems as if either object of that special faculty when we do mathematics or sciences is going to be very close to something like the metaphysical realist view of an abstract object. And I just want to add, it does seem as if whichever view you take about the objects of dianoia, that they can be the objects of thought while failing to be the objects of knowledge, right? So yeah, I was curious what your response was.
Yeah. So I don't know if you have the handout or I don't want to waste time, but if we want to go really into detail on that, I'm happy to do that. But if you go back to the divided line, so dianoia is that which we come to know by thought. So it's the faculty of thought as opposed to the faculty of understanding. And again, the idea of thought for Plato is a conjectural notion. And so you have the divided line, which is in book 6, and that's where Plato is struggling with exactly that question. Exactly the question of, well, look, God, if anything is knowledge, it's mathematics, right? If there's anything we want to call knowledge, it's got to be mathematics. And they end at the end of the divided line, and he says, well, it's a kind of knowledge, and he leaves it there. And what happens, especially in philosophy of mathematics, not so much in Plato scholarship, but certainly in philosophy of mathematics, is people will stop there and they don't go on to book 7. And in book 7, he takes up, no, we've got to be clearer on what is the distinction between mathematics and philosophy. What is the distinction between dianoia and dialectic? And the faculty of nous, right? Because it's nous, it's understanding that relates to the forms. And right at there are a lot of reasons why this confusion arises. And I don't want this to become Plato talk, but I will say, here's one of the key quotes, and it's in book 7, and I think it's at 534, but I could be wrong. If you send me an email, I'll get you the exact quote, where he says, so remember in the other part of the line, we have opinion and belief, right? So opinion relates to those that we know by imagination. Those are the images or the shadows. So we have opinion, belief, and then we have knowledge and understanding, or thought. He takes away the term knowledge. He says, and we're not using that anymore when we talk about mathematics. So we have thought, then we have understanding. And then he says, knowledge is to belief. So he runs, a kind of analogy. Knowledge is to belief as thought is to imagination. To imagination, right? And so that's how we're to understand objects of mathematics. It's not willy-nilly, I get to say, well, I think a square is this. And where mathematics really differs from, our knowledge of, say, a table, is that I have a definition. And it's the stability of definitions that makes mathematics really a science, right? So it's the hypothetical method, but the hypothetical method wouldn't mean anything. And he's clearest about this in the Meno, where he, remember they're being asked for a definition of virtue such that they can decide whether it's teachable or not. And he says, let's do the same thing as mathematicians do. Let's set up a definition. Set up a definition, and he says, like the mathematician's definition of shape or something like that. And then what do? They solve this problem by taking the diagonal as the length of that line. And what's key in solving that problem is we have a stable definition of what a diagonal is, right? And because we have that stable definition of what a diagonal is, we can construct that square. We can use the Pythagorean theorem. We have all of these mathematical resources, but we didn't need the object, right? So I do think, there is a lot of confusion, and I'm happy to have conversations with you. You could just throw me an email. Another big project that I'm working on is working out exactly what's going on in Plato and why. Yeah.
Great. Yeah, thank you. I'll email. Yeah, my concern is just whether the objects of the conjectural type of thought are abstract enough. Yeah, in Plato's mind. But yeah, I'll email you.
It's
Thanks,
interesting. I just want to get one thing in. So Aristotle, in his typical Aristotle way, makes fun of Plato and his view of mathematics, but he does say one thing, and I think that it's one. He says it's either in Metaphysics Mu or Nu, and I can't remember which one, but he says, mathematical objects are prior in definition, but they're not prior in place. And I think that captures Plato's view more accurately than any Platonist position on Plato.
Chris, do you want to stay in the queue?
Yes, please. Thank you.
Thanks. David, please go ahead.
Well, thank you for that. I'm very sympathetic to your project. As you know, I'm old enough to have been trained by Carnapian anti-metaphysicians. So I'm very anti-metaphysical myself, but I just wondered what, and I think I lost my sound when Edward was talking, so I may be overlapping with him a little bit, but I wanted to press you a little bit on the kind of anti-foundationalist view that you have here. Because it seems to me, I mean, and again, I'm playing devil's advocate because I'm sympathetic, but I want you to say a little more about, I mean, you say, well, okay, well, you look at, you have to have a background theory in order to make your analysis go forward. But that background is not an absolute. It's not a ground, as it were. It's just another as-if theory. But what if someone, it seems like you're setting yourself up for an infinite regress or something, like, well, then there must be a theory behind that, and there must be a theory behind that. And someone might press you on saying, well, the buck's got to stop somewhere. We've got to get to solid ground at some point, and real objects, and in a full-blown realist sense. And I think there are answers to that that don't accept the need for an absolute foundation. But I just wondered what you would say to someone who is trying to press you on saying you're setting up an infinite regress, or you need some final solid ground.
Yeah, so I think, in fact, Stuart Shapiro has made that charge against me.
Okay.
Yes, but I think, so it's interesting. So the tale of how the development of this as-if approach came about was both Stuart and Jeffrey for years were saying to me, look, this is of my project in using category theory, this is just if-thenism, and it's going to lead to a regress, right? Or Hellman would say, look, you've got an if-then in there, you're going to face the vacuity problem, and so it was in light of exactly the consideration that you're bringing up that I started thinking, look, this isn't if-thenism, because I'm not trying to run, if category theory, then we have, a foundation for mathematics or whatever. But I do understand the objection, which is, if you're going to say that, I do think we need a meta language for structure, right? So if we're going to say, as a mathematical structuralist, that mathematics is about structure, right? And we've got these examples, we've got, groups and topological spaces and sets and categories, and then we need, a framework for talking about those. And I take category theory as that framework, right? So that's my mathematical level at which I'm saying, if, category theory consistent, right, then I can get examples of categories. So category of sets, category of groups, category, so forth and so on. And then, so here's Shapiro's reply to that is, fine, you can be a structuralist at a mathematical level, but you need now something that's going to guarantee that, category theory is consistent. And typically that's going to be set theory. So really, it's all about set theory, or you're going to need some theory in the background, and maybe it'll be his structure theory, or maybe it will be Hellman's modal,
right,
whatever. You get the idea. And my response to that is, okay, I'm going to need a background theory, right? I'm going to need something that allows me to run a relative consistency proof. That's what I need the background theory for, to run a relative consistency proof. But I don't need, when I say, okay, I'm going to assume as if my background theory, for example, was set theory, I'm not saying that's ontologically prior. I'm not saying it's, now we're getting into Pfefferman a bit, right? I'm not saying it's epistemically prior. I'm not saying it's logically prior. Right. What I'm saying is, I need this to set up a relative consistency proof. And it's in virtue of setting up that relative consistency proof that I'm going to take set theory as if it were true. But notice that I could run it the exact opposite way. I could say, no, I don't, but one could imagine saying, it's set theory that's the theory at the mathematical level. That's the theory that allows me to give all these structures. It actually doesn't, because the geometric ones are problematic, but okay. And then, my background theory is going to be category theory, because that's the theory that I'm going to take as if it were true to give an interpretation for my set theory. So let's give an example, right? So we've got Hilbert. There's Hilbert. He gives the axioms for geometry, right? And then what does he do? He gives a relative consistency proof of them. So he uses real analysis and he gives an interpretation of the axioms using numbers. Now, no one jumped up and down and said, so analysis is the foundation. So you're going to have to take that theory as true. And the reason why they didn't was because they understood that it was for the methodological purpose of providing a relative consistency proof that I made that assumption. It wasn't for a foundational, whatever we mean by foundational, ontological foundation, epistemological, whatever, metaphysical foundation. It was, no, I've got to get on with this task of justifying why it is you get to take those as consistent. And it's in virtue of that meta-mathematical task that I did that. Now, Frege did have a problem, and he's like, no, wait, you're telling me that points are numbers? Points are not numbers. And again, that's where we get into when we start reading background theories in ontological foundational ways, instead of just this very pragmatic, I've got to use something, right? So I don't think there's foundations. I think that there are theories that are better used for relative consistency proofs because they're more expressive, because we have more, we take them as more stable. But I don't know that that's going to commit me to the truth in the sense of ontology truth.
Right. Well, I guess all I'd say is that I think it's a tricky thing to convince someone who thinks that you need what Frege thought, for example, what thinks that you need some kind of absolute to convince them that no, you really don't. You can really stay at this mathematical level, and it's as if, and I mean, I think more needs to be said there, but I don't know exactly what would convince someone who's already got that, philosophical bug, and wants a foundation. Like I say, I'm myself am very sympathetic. I don't have that bug, but anyway, I can just see someone doing that. But anyway,
I will say, I think the foundational bug, I like how you put that. I think the foundational bug remains because people are confusing, again, this mathematical method with the metaphysical method, because the terminology, it's the same, right? It's like, well, that's a hypothesis. You've got to show me that you're justified in taking that as a hypothesis. I need some first principles, right? Like, the language is the same. And I think if we really look at, and I know I began in this kind of way about talking, about whether my mind was going to be sullied by philosophy, but I think here's the sullying. The sullying is, if you're developing an account of mathematics that doesn't pay proper regard to the actual method of mathematics, and when I say that, I'm not talking about whether it's a semantic method or a proof theoretic method. I mean, we now have a lot of methods, right? I mean, we're not in the same kind of Hilbert time of, no, all methods are proof theoretic. We have proof theoretic, we have semantic, we can change our logic, we can give a diagram now, right? There are many ways in which we can justify our method. But what I'm trying to get at is, none of those ways require of us that we justify the hypothesis that we begin with in this very robust metaphysical way.
All right, I'll intervene because we have a really long list of questions.
Thank
My
you.
fault.
All right, Vasilis, you're next.
Hello.
Hello.
Thank you very much. Your argument was very, very convincing, I must say.
Good.
Now, I have two very brief questions. I remember some years ago, you wrote a paper about Minos paradox in Plato. And there was a debate at that time. Some people were proposing that there's a continuity between thought and the dialectic, that somehow thought is the first stage of the dialectic, and you held the opposite opinion, the one that you presented today. The question is, are you aware of any, whether this discussion is still going on, or is the question settled? The second question is about this background theory. Now, you explained it before in the previous question. What I want to ask you is, when you resort to a background theory for whatever purpose you want to resort to it, do you have any criterion how to choose one? Because it seems to me there's a plurality of such background. Your approach is open to the plurality of this kind of structures and theories.
Great. So the first question about is the method of the hypothetical method part of the dialectical method? So that, you're right, that debate was an ongoing debate at that time. It's still, I believe, so the person arguing in favor of that view, and again, not from a philosophy of math perspective, really from a Platonic or a Plato perspective, is Hugh Benson. And Hugh Benson is someone who believes that there is only one method, but it's one method that has two stages, right? So that your first step is to take the hypothetical method, but then your next step is to say, okay, what is tethering these hypotheses? And so presumably even that the mathematician is going to have to adopt the dialectical method at some point and then give first principled accounts of his hypothesis. So in the literature, so Bill Tate is very close to that position. So he thinks that what happens is that you then look to geometry. Plato looks to geometry to provide those first principles. Another interpretation is to say Plato just doesn't even consider whether this is part of that. And that's the view of Bernier. So he says Plato's just agnostic about which direction you should go. Here's why I think they're distinct methods is Plato takes very much effort to say, not only are those methods distinct, I mean, look at the language that he uses. He says the mathematician is forced to use hypothesis. He uses forced, has no other choice. Now, part of how that works itself out is if you then look at how Plato gets interpreted. So some people, again, it's Plato scholarship. So for everything I say, there's 20 other people who disagree. So some people believe that mathematical objects are these things called intermediaries. So they're intermediate between forms, they're form-like, but not quite forms. Again, when you look at the text, there doesn't seem to be anything to suggest that Plato takes objects as form or even form-like. And in fact, again, at the end of book 7, as I was saying, he likens thought to imagination, right? Like, how could something that's like imagination have objects that are forms, right? So I think for me, these are very distinct methods. One is not part of the other. The second question of the criteria of choosing a background theory, again, look, I think background theories get chosen with the questions that you have in mind. I don't think that there's a fixed background theory. So what do I mean by that? Because, you know, I have books and publications arguing that category theory is a foundation. But what am I saying? What I'm saying is category theory is a foundation for mathematical structuralism, right? So what it's saying is, if my problem is, how do I talk about structure in mathematics? Then for me, the best theory for doing that is category theory. But suppose I didn't want to talk about structure. Suppose I wanted to talk about, I don't know, relations, you know. Well, then maybe my background theory would be, I don't know, type theory. I don't know. But it's again, and this is what the methodological part, this is the part where I'm really building off of what Maddy has been doing recently with this enhanced if-thenism, is to say, you choose what you're going to take as your background theory on the basis of what the problem is you're trying to solve. And you know, for me, category theory is much more expressive about talking about structure than set theory is. And I don't know, suppose I was talking about, you know, objects and relations. So suppose I this is perfect, right? So suppose my object language is logic, right? Where I have talk about predicates and relations. Well, you know what? My background theory should probably be set theory, right? Because that's the theory where I now say, okay, if I want to do that in a consistent way, then I need some talk about extensions, right? And the best way to do that is through set theory. So it really does depend on the problem at hand and the problem that you're trying to solve. I think a lot of people, when they looked at my work, thought, oh, I'm just arguing that category theory is the foundation as opposed to set theory. And no, what I was trying to say is, if you want to be a structuralist, this is a better language than the set theoretic language. But I do think ultimately that it is a very pragmatic decision about what you're choosing as your background theory.
Thank you very much. Okay.
Thank you for joining us. Wilfried, you're next.
I first of all wanted to thank you for your talk. It was very interesting, informative. And I'm sympathetic to some parts of what you said. And the parts that I find sympathetic, or I have sympathies for, is simply to distinguish, if you wish, philosophical structuralism from mathematical structuralism. So, but I wanted to first of all tell you, there is a German philosopher, Kurt Feininger, who in the 1920s defended als ob philosophy, as if philosophy, and particularly also philosophy of mathematics. So Berner is the collaborator of Hilbert's, found his views quite sympathetic. In 1930, he wrote about Feininger, and so no, that's quite congenial. So, by any event, I wanted to make remarks about Hilbert, because I think there are really two Hilberts. The early Hilbert you talked about, and the later Hilbert starting in the 1920s when pursuing his finitist consistency program. The early Hilbert, his perspective on mathematics is really rooted in Dedekind and in Dedekind's methodological views. So what did Dedekind try to do? To introduce into mathematics abstract notions, even in the case of number theory, right? I mean, when he introduced natural numbers, he did this indirectly by introducing this abstract concept of a simply infinite system. And it is that kind of perspective that you give an explicit definition of such an abstract concept that was taken over by Hilbert. In Foundations of Geometry, he does it. He gives explicitly a definition of a Euclidean space. In the contemporaneous article on real numbers, he does exactly the same thing. He introduces an abstract concept of a complete ordered field. So I think that is one Hilbert. And I think I would find it very difficult to find explicitly how you interpret it, namely that this axiom system gives an implicit definition of objects. That, there's a question. Where can one find that particular perspective of Hilbert's? So that is one question, right? I mean, if you wish, a historical question. I mean, in the correspondence with Frege you mentioned earlier, he says quite explicitly, if you, Frege, don't like my use of axioms, forget it. It doesn't matter to me. You could as well replace axioms by characteristic condition, in German Merkmal, of my abstract notion. So that he uses axioms is completely irrelevant. But be that as it may. So that is the early Hilbert, and I don't think that one can attribute to him, or I would like to know how that his axiom systems give an implicit definition of objects. The later Hilbert, and there I'm a little bit puzzled, right? I mean, there he is explicitly trying to prove consistency by now available proof-theoretic techniques. And this whole program was expanded in the last 80, 90 years to a relative consistency program. And, you know, there are distinctions to be made between different theories. And I'm wondering whether one simply should say, okay, everything is possible, you can do this, that, and the other, but are there some distinctive features of the theories that the proof theorists have been using? Okay, so there you have my two questions. One concerning Hilbert, the early one, and then later Hilbert, and how proof theorists expanded matters.
Excellent question. So I think elsewhere, to be sensitive to what you're saying about the early Hilbert is, I called this a rational reconstruction of Hilbert. And I wasn't so careful in this talk, and I should have been. And so I'm attributing to Hilbert this you know, kind of global position that axioms are implicit definitions. And that is an overstatement. And again, perhaps it would have been better of me to use that term that philosophers like, my rationally reconstructed Hilbert, instead of the historical Hilbert, because I think you're right. I think that there's many things going on in his discussion with Frege, though I think one of the things that is very different is Frege does believe that there is only one fixed interpretation.
Oh yes, I agree.
Right, yeah. And Hilbert allows for multiple interpretations, right? And so I think that's what I'm trying to pull out, and that's what I'm trying to capture. And as well, so I don't know so much that, and I think you're right, I need to be more careful when I say Hilbert and everything's implicitly defined, because even if one means that in geometry, there is it's only in geometry, right? It isn't a claim about axiom systems, let's put it that way. So all I wanted to point out from my rationally reconstructed Hilbert was, one, no fixed domain, variable domain, and two, that for Hilbert, right, you have that existence is a consequence of consistency and truth, right? You don't have the other way around, as it is for Frege, right? And those, so I think you're absolutely right, and I need to be more careful. And, you know, so just to let you know, this is hopefully going to become a book unless it all gets shredded. But as one deals with the historical Hilbert, of course, one needs to make the distinction between what was actually going on there and what I'm trying to pull out.
Yes.
So that,
may I make one quick remark? Variability of interpretation, right? As a structuralist and category theorist, you should be delighted by looking at it, by Dedekind, right? Because after all, I mean, he is the first who does that sort of thing, establishing that the notion of a simply infinite system is, as a matter of categorical. Okay, sorry.
No, I think that's right. I mean, there's some interesting things about that, and we can, yeah. So the second point about relative consistency proof and the proof theoretic kind of methods that go into that, again, absolutely. So that what I'm trying to do with the as-if-ist approach, and what I'm trying to avoid by making relative consistency proofs proof theoretic, fundamentally proof theoretic, is in the philosophical literature, right? That then kind of drops down to some form of if-thenism, right? And it brings with it this idea that we have to have one method of proof. And what I want to allow when I just talk about, you know, this structural as-ifism, of course, you know that relative consistency proofs are going to have to bring in proof theoretic methodologies. What I'm trying to avoid is the presumption that there's one logic that's going to give us these proof theoretic methodologies. So I want to allow for a flexibility or a plurality of proof theoretic means, and not tie myself to, and this is the way to do a relative consistency proof.
Okay. Thank you very much.
Thank you very much for joining us. Colin, please.
Excuse me. So thank you for this talk. I'm learning a lot. As a warm-up to my rather amateurish question, you asked for a suggestion for names. So if you just switch methodologically interpreted MI and as if AI, you get AI MI. So you can call yourself the amiable account. But my question is a bit more from left field. You know, I'm not a mathematician. I'm not even a philosopher mathematician, but I've hung around with a few of each enough to know that mathematicians sometimes strongly resist the idea that anything that they're working with is not real in some very robust sense, right? And it leads to a kind of mathematical mysticism, of course, in some ways. But it also seems to reflect their understanding of what they're doing. And I'm just wondering whether your account just has to dismiss those kinds of things as misguided in some way, or can accommodate or explain that kind of robust sense, despite these objects being as if objects, or is it just irrelevant to your project?
Okay, so I think that question is at the very, very heart of this project. It's in virtue of the desire to give back mathematicians their notion of claims of existence that I'm doing what I'm doing. Because again, once you accept that once you make the decision that your hypotheses get to be treated as if they were first principles, once you make that, then you've got existence, right? Because I've said it as you've got as if existence, right? But because I'm talking to a philosophical audience, because what I'm trying to do is say, look, that notion of existence is different from metaphysical existence, right? So I'm using the phrase as if existence to say to philosophers, this is not metaphysical existence. But as a mathematician, you're just saying exists. You're just saying exists. And when someone says, oh, exists independently of us, that's what you mean, you're like, no, I just mean exists, right? So, and it's exactly that notion, that mathematical notion of existence that I'm trying to give. I can't stress this enough, the only reason I call it as if is to contrast it with metaphysical notions. So notice at the very end of the talk, I said, look, there's two notions of existence at play. There's the as-if notion, and then there's the physical notion, right? Because I don't believe in metaphysical notions of existence. And when you're a mathematician, the as-if notion is the only notion. So you can take away the as-if.
Yeah, good. I mean, so a bit more full disclosure here. I'm the one who forwarded the talk announcement to Ed Zolta, so he was the ringer here, and I spent a lot of the talk I didn't know he was here because you can't see the participant list. So what would Zolta say? And so what fortunately he said it first before I had to try to channel him, but it struck me that a lot of what I've picked up from talking to him with some regularity, as he said himself, puts just in different words very much similar points. So he threw out in his question, or in the interchange between the two of you, this sort of difference between objects that encode and objects that exemplify properties, right? And yes, so existence as a special predicate, as this philosophically, metaphysically thick one, is one that actually applies only to exemplification, right? So the fountain of youth isn't exemplified, but it's encoded in an abstract object, which you would call an as-if object. He would just call it an abstract object, it seems to me, right? But you think, but to answer my question, you think that the mathematicians are going to be perfectly happy with the idea that this is what they are thinking about when they are doing mathematics, essentially, and that for you is sufficient to ground the kind of rejection that many of them have, that they're dealing with things that are made up or just in their heads or meaningless pushing around of symbols or anything of this type, right?
Yeah, look, and this is, and it's hard to do. I'm not bringing in Wittgenstein. I'm not going to do it. But here's one way of looking at it, right? When I say I treat two as if it exists, right? There's no other notion of existence in mathematics, so I claim. So what I'm really saying is I treat two as existing. The reason why I characterize it as an as-if is because I also want to bear out that when I go to use mathematics in science, for example, I can't move from as if exists to exists, because that means something different. So there is, in mathematics, there is no difference between exists and as if exists. They're the same. But in science, right? So if I were to say something like, I treat Santa as if he exists, what that means is, look, I can create a language, I can create a narrative, all of the typical things we're told about fictionalism and reference to physical objects or as if objects. But the thing is all the while we know that there is another notion of existence. And that's what allows us to say it's not as if, right? But in mathematics, remember what I'm doing. I'm saying, I'm going to start off by assuming that my hypotheses are first principles. And in virtue of that hypothesis, of that claim, that meta claim of I'm treating this hypothesis as if it were a first principle, then I get to treat those objects as if they exist.
Great, thank you.
Yeah.
All right, we have 2 more people and Chris and 10 more minutes. Sandy, please, floor is yours.
Thank you, Elaine. That was really interesting. And if Colin described himself as in left field, I'm in a whole different ballpark. Or treat this as the naive student who was inspired by things you said, but doesn't play in this park. And I was really intrigued and really interested in the methodological approach you take and the pluralist approach. But you said something, and especially the claim that mathematics is a language and not a science. So one of the questions I have is you referred to the stability of definitions as playing a major role in the way in which the practices of as-if-ism play out. And I'm curious about what secures that stability. So what I have in mind, of course, I'm the person who's read one book in philosophy and mathematics, and that's Lakatash's Proofs and Refutations, which suggests that the stability of definitions itself is a negotiated outcome that may align with what you were saying, that they're driven by particular problems you want to solve. So I just wanted to hear a little more about what it is that secures this, what it is that makes these definitions stable across what? I mean, I'd like to hear a little bit more about that.
Excellent, good. So I think one of the things that I did leave out of this discussion, though I think really does need to be brought in to answer your question, is the distinction that Hilbert makes between genetic method and axiomatic method, and which also lines up with what is it called, method of analysis and method of synthesis, that one finds both in philosophy of science and in philosophy of mathematics. So, suppose we want to define a concept like a group or a set. We might start out, right, with Lord forbid, our intuitions, whatever that means. So, Hilbert considers this too, because he's writing at the time when, Kantian kind of views of geometry are still around. He says, look, you could start out with intuitions, you could start out with observations, you could start out with, if you're looking at this question from a historical question, well, what did we mean by group in this context? And what happens is you get more and more precision, right? You say, well, I mean this, and I don't mean that, and I mean this. And then you get to the axioms, right? And the axioms encode what you mean, right? And that's the sense in which I do take the axioms as implicit definitions of your concepts. Then what happens, and this is, how there's various analogies for this. So you look at this as I'm climbing towards my axioms, then I kick away the ladder, right? Then I say, I don't need, because I'm doing mathematics, I don't need to tell you a story of how I got to that concept. I've just got that concept. And so what in answer to your question, there's two things to say. One is, the history that got you to that concept, that's part of it. And then there's the encoding that takes place once you get to the axioms. Now, there can be rivals, right? When we look at set theory, for example, there are many different rivals, axiom systems for what we mean by the concept set. And there are many, there are contexts in which one definition works better than the other. So, if we're in contexts where, we're looking at, the size of a set, for example, it might be beneficial to look at something like a Gödel-Bernays set theory, where we can talk about the distinction between a class and a set, right? So a class being bigger than a set. So we have that distinction to play with. If that's not something you're concerned with, or that plays out in the solution to your problem, okay, you might be fine with ZFC. Mm-hmm. Again, if you're not concerned with how functions arise out of sets, if that's not a consideration for you, you might choose something where you've got the axiom of choice. But if that's a concern for you, and it was for a lot of mathematicians, like, I don't want choice in my system. And so getting back to your question, I think the definition of your concept gets fixed by your axioms, but the choice of your axioms is dependent on the problem you're trying to solve. And I think one of the things that's happened in philosophy of mathematics is we think we're all solving the same problem, right? And that's what gets back to David's question of, well, don't we need a foundation, right? We're trying to solve the problem of existence. And I'm like, no, we've solved that problem. We don't, you think the problem is you think that that's a metaphysical question, and I think it's a pragmatic or a methodological question. Does that help?
Yeah, no, thanks. That was very helpful. Thanks very much.
Oh, thank you, Sandy. Ken, floor is yours.
Hi, Ken.
Hi. Good to see you, and thanks for the talk. I'm trying to stand sort of way back and listen to the whole discussion. It seems to me that when you're pushed by the tradition, the shorter tradition, the Anglo-American, Shapiro and so on, and you say you have to have a background theory and somebody wants a foundation and all that. And that's not where you're at, that's clear. So the thing that you're not willing to respond to these people is that in a practice perspective.
Yes.
Okay, in a practice perspective, we have a confidence in the possibly disputative, whatever it is, but we have a confidence in the process by which the means of attacking a certain problem intellectually are attained. And I think that's really where you're at, and you're not acknowledging it. For example, you feel that when Lakatos gets brought up, you have to move to distinguishing genetic, etc. But Lakatos is just a fine example. Well, it's not exactly history, but we know all that. But the process that Lakatos is bringing us into his kind of contact with is precisely a process where people are sorting out how you deal with those Euler count phenomena, as I like to call them. And so that's, I think, where you're at. And the awkwardness with the Anglo-American tradition is because they are so unwilling to have any confidence in such processes, feel that they need to account for them necessarily. In this regard, it's a little misleading where you start from in Plato, because, well, it's true of sort of individual instances of mathematical practice that would include, say, in Lakatos, individual participants doing their thing, that you take, you just proceed from where you're at, as if there's no question. And historically, maybe Plato wanted to cast geometry as that way, though we know that there were challenges made, and he's clearly trying to take this strong position so as to allow mathematics to avoid those challenges. But the truth is that the the dialectical side is as much represented in your view of mathematics and the phenomena you're dealing with. There's no conflict between the dialectical perspective or practice perspective, where we have confidence in the controversial moves in a practice that lead to the best, to an adequate way of solving a problem on the one hand, and on the other hand, the fact that a particular mathematical proceeding, as it were, internal mathematical proceeding, just starts from where it is and does what it wants to do. That's the mathematical way of it. Well, that's my thing. So thanks.
Yeah, I couldn't agree more with everything you're saying. I think, so two things I want to point out. One is, I think that a lot of kind of motivation for what you've called this Anglo-American comes out of a time when there was, vast instability in mathematics, right? So we had Frege, and then it was, oh my God, we're going to get Russell's paradox. And then it was, okay, we're if we move to ramified type theory, now we're committed to, axiom of infinity. And what does that, so there's this time of flux and change, and what are the right axioms? And I don't think we're in that state anymore. However, I still do think that questions about, is this the right definition for this task, are very, very meaningful. And I think that is an ongoing debate, both amongst mathematicians and amongst philosophers. If someone would have said to me when I was offering up category theory, is category theory the right language for talking about structure? That would have been an interesting question. But the debate was, that's got to have an ontology. Category theory doesn't have an ontology. You have to use set theory, where the debate went. So I think you're right that I'm not trying to gloss over the fact that still right now, there's a question even amongst practicing mathematicians about, is this a good definition? Is this the right axioms? And going back to Plato, I think that was the case even for Plato. So there's another vast, and I'm going to say this in 2 minutes, but it is a well worked out project. The other thing that is going on in the Republic, in the divided line, is Plato is fed up with what he sees as the practice of mathematics, or mathematics as practice. And he says what the problem is that they're basing mathematics on diagrams and figures, and they shouldn't be. To the point about there's still a role, an active role to play, even if you say, mathematics is about setting up hypotheses. There's still the question of, and this is a question for Plato, what do we take the numbers to be? And so in the Republic, Plato organizes the mathematical disciplines, right? So you have arithmetic, and then you have geometry, and then you have spherical geometry, and then you have spherical geometry in motion. And the very last is the theory of proportion. So there's another project that I have that's ongoing, that's part of this project, is to argue that what Plato wants to be doing there from a mathematical perspective is say that we should be treating numbers as geometrical measures and not as units. It's only by viewing numbers as geometrical objects that we're going to get things like irrational numbers, like the 2√2 that we need to construct our square. So I'm certainly not, this view that I'm presenting isn't a view of mathematics as just reason from hypothesis, you know, nothing could possibly go wrong. A lot of things go wrong, and those things that go wrong push us to better definitions, and not, maybe that's the wrong word, to more precise definitions, and to demonstrate why that definition is useful for this purpose.
All right, I think we should probably stop here for today because it's already 5:36 and the Q&A has been going for already more than 1 hour, 15 minutes. So thank you very much. Yeah, I know, you must be exhausted. Thank you very much to all of you for joining us for this lecture, the annual lecture series this semester. It's been a really lively Q&A, and thank you to you, Elaine, for this really exciting talk, as we've seen by the Q&A. Actually, people were really quite interested. If you don't mind a meeting with some of the fellows afterwards, I suggest you take a 10-minute break so that you can refresh yourself, and maybe meeting around 5:45 or something like that.
Perfect. Perfect.
All right.
Thank you everybody for amazing questions and for joining me. And thank you to the organizers again.
All right, so we hope to see many of you for some of the further lectures at the center. Have a good weekend.